Hello everyone. Today I'm gonna introduce an educational application for AI learners. In the artificial intelligence class, we usually start with the topic search. The typical search approaches are breadth-first search (BFS), depth-first search (DFS), greedy best-first search, and A-star search. And when we evaluate these algorithms, we consider their completeness, optimality, time complexity, and space complexity. That is what we usually learn from the AI class. But how do these algorithms perform in a real search problem like game playing? In this application, we let AI solve a maze game with different search algorithms and see whether they perform just like we thought they do. Here is the user interface of this mobile app. You can choose which search algorithm you would use from BFS, DFS, greedy best first search, and A-star search. And if you want to see how they perform in another maze game, you can use the reset button to change the maze map. Can you see? The map changes. All the maps are generated randomly. That makes it possible that algorithm can be tested in different maze environments. In the middle of the UI, you will see a very hard maze game. Actually, this maze has more than one path solution. You can play by dragging the dark blue cell block along the path like this. Here, for example, there are several optional paths you can choose, and each of them can lead to the goal. Thus, when we use different search algorithms in the same maze map, we can easily see which one provides an optimal path solution. In fact, if we choose an algorithm by click any of these 4 buttons, the length of the solution path is counted and listed on the left bottom. It is convenient to make a comparison of all the approaches. In this case, the path length of BFS is 97. A-star is 97 as well, because both of them guarantee the optimal solution. The path length of DFS is 157. The greedy is also 97. Let's try another map. BFS is 109. A-star is 109, of course. Greedy is 135. DFS is 145. Let me introduce another function in this app. This is also the most fantastic function. Show steps checkbox. If you click it and run, you can monitor the whole process step by step while the AI is searching the path. You will see what situation the AI meets and how AI makes the decision. In BFS, we can see the path flash out alternately because the algorithm changes branches frequently if the goal is not reached. So far, we can see main 3 branches. And finally, it reached the goal. In DFS, the path looks much solid because only when reaching a dead end, AI changes to another branch. A dead end, another dead end, dead end, lot of dead ends, finally reach the goal. Greedy best first search prefers the path toward to the right or bottom. A-star search gives a mysterious path-finding process because the estimation costs include both the cost it has passed and the cost it will go. By the way, the heuristic function in A-star and greedy best first search is defined as the straight distance from the successor node to the goal. How do you like this mobile app? Do you think it is a friendly and helpful tool for search algorithm learning? When I use this app, I found that BFS gives a much better path solution than DFS does most of the time. Another interesting conclusion I found is that although only BFS and A-star are guaranteed to provide an optimal solution, the path under the greedy best first search often matches the optimal path. It might be because of the particularity of this maze game, but it is a good experiential understanding of picking a search algorithm for AI problem. So, what's your understanding through this app?